Well, hi, good morning. It's July 21st. Kind of a semi-cloudy, rainy, sunny day. Everything's coming at us, hot and humid, but again, nothing like it is in other parts of the world. So, no complaints here. Now, what am I going to do next with this radio? So, there's a couple of different approaches I could take here. One is I could focus on the audio side of things down here, clean up all these capacitors. The sort of the opposite approach, or the other approach, is to work on all the stuff up here in the RF part of the radio, clean all that out, change all these capacitors. I could try to identify each capacitor as I change it, look on the schematic, find out where it is, determine what it does, and then change it. That's an awful lot of effort, and I don't think there'd be much value in doing all that. I think what I'm more inclined to do here is just get in there and start changing them. Don't have to really identify where they are on the schematic, unless I can't read a value on one of these. I should be able to take it out and read the value. But you notice that they move the camera so you really get a good look at this great big one here. This one I think we'll find on the schematic, and maybe this big one too. You notice they're both soldered down to the chassis, so they're connected to ground. This one looks like it might have even been replaced, but I don't think so. Very hard to solder onto the chassis, and you can imagine back in the day when they were building this, their soldering irons were great big long things. In the earliest days, the soldering iron, when you stopped using it, you put it into a holder with a blowtorch blowing on the end of it. And then you took it out of the holder when it was hot. It was a great big hunk of metal at the end with a point, and solder away. Can you imagine working on these things with a big clumsy soldering iron like that? But soldering to the chassis is very difficult because the chassis takes the heat away really quickly. So you need a very hot soldering iron with a lot of thermal reserve in it. You can't have a little tip. You can't have a little tip like that. That's not going to do it. So that's why the solder might look kind of roughed up. See, this looks really nice up here. It's nice and smooth. This looks like solder on top of solder on top of solder. So, maybe work has been done in here. It's really... Well, we know this got untwisted. We know there's a wire to nowhere here still. A wire to nowhere. I wonder if I should settle that. Let me take a few minutes and look into that a little bit further, because now I'm more familiar with the radio schematic and all that stuff. Maybe I can sort out where the wire to nowhere is supposed to be going. Yeah, I'm going to do that off camera because I'm going to be quiet while I do it. Okay, so it turns out, just from looking at it visually, it looks like that wire is connected to a terminal that is connected to the chassis, and there is a ground on it. And sure enough, if I take my meter, put it on the ground, and then touch the end of this wire, which I'm going to give you the other camera view here. This is what the other camera is seeing. It's a little bit confusing. Let me wiggle the wire in question. You can see what's moving. You can also see what's not moving. You can see the wire that is soldered to the chassis there coming up, kind of bending around behind another wire, then coming over. It looks like it's going to the wiggling terminal, but it's not. It's going to a terminal behind it. That's why it's not wiggling. Let me just make sure you know what the heck I'm doing here. This is what I'm doing. Grabbing the end of the wire and just going like this. And you're looking at it. That's what's happening. So it does not appear to be connected to the grounded terminal. Yet, if I stick my meter in there, it's the first time I've done this on a camera like this. Okay, make contact. I think I'm making contact. I'm going to touch the chassis with the other. Pretty convincing it's on ground. Now I've rotated the band switch through all the different settings and repeated this, so you get the same. Everything is grounded. Doesn't matter what you touch. Touch anything, it's grounded. I'm working right next to my gosh. How do I know for sure I'm touching the right thing here? It must be, my lead must be grounding, my test lead must be grounding on something else also on the way there. Well, you know what? I'm doing the end of the wire for crying out loud. So I'm uncovering the end of the wire here, taking that yellow cover off. No question now where I'm going. You heard it. Okay, so there's a ground on that wire. Or that wire is an extension of a ground. But it seems to be going to the switch. And it does not seem to be going to the same terminal as the ground, but it seems to be permanently grounded. What? Let's look at the schematic here, and we can add to the confusion here. Okay, so the wire that I'm curious about appears to be coming from one of these three terminals right here. Let me zoom in on that a little bit. Okay. Actually, so this can't be it. No, here we are. You can see this isn't adding up at all over here. Here we are. So you can see one lead or one terminal is connected straight to the chassis ground. The curious thing is, what is this dotted line here? Which I noticed earlier. I don't know what that is, but there it is. Then we have the other wires coming off and heading up. Oh my gosh, well this one's going right to the tuning capacitor. So this is the major, I don't want to call it the major, but this is a really critical connection. And it's, so you're going to rotate this a number of snaps. It would almost strike me that at some point this wire is disconnected completely. Is that possible? I mean, well, there is another. Wait a second. This isn't what it appears to be. You gotta be careful where these dots are that show wire connections. And where there's no dot, there's no connection. So here they're feeding this section down here. This section is probably working against the antenna. And this section is probably dealing with the local oscillator, it's coming over this way. So this is probably local oscillator. Does it even say? Maybe it says. Well, it's got numbers, C12, 13, and 14. You can probably figure that out somehow. So how's this help? So it doesn't really help much. Identifying what that wire is. Because at this point it appears to be an extra wire not shown on the schematic, which I can't imagine that. Isn't it one of these two and they've been cut? It would be, I don't know which one yet. Still trying to, well, one of these goes to the tuning capacitor. Should never have a ground on it. Well, unless you flip the radio all the way into phono. Maybe in phono this switch then places a ground. I don't know, I hate these switches. To be honest with you, I probably don't even have the rotating thing going the right way here. Did they indicate it? They just tell you front and rear, and they leave it up to you to sort it all out. That's why I don't like these switches. Okay, so I'm still nowhere on where this wire is, what it's doing there, why it got cut, and what's the problem with it laying there cut like that. I never found another end, what was cut away. I'd have a very hard time imagining that there's a capacitor going nowhere in there, but there's still serious performance problems with this radio, so there could be something stupid wrong with it, like that cut wire. Okay, I'm going to have to look at it more. It's not enough yet. Okay, so what I'm trying to do here is achieve absolute certainty on what this wire is. I'm just having a little bit of trouble because it's hard to see back in here. So, let's see what we can do. So we trace all these terminals back one by one and see where we are. So first we're going to start on this side. And what I mean by that is this is in the picture, this is the top of the switch. So in the picture, this is the top of the switch here that we're looking at. So this is the section we're looking at. It says rear. So viewed from the rear is this way. This is the rear. So we see the rear going down here has a pile of wires going straight to this coil. And there's the capacitor I replaced right there earlier. So if we look at the schematic, we say from the switch, this side, a pile of wires. Now they look really long on the schematic, don't they? And they go to this tapped coil here. And that's what this is. This is a tapped coil. And I can see one of the taps, but you probably can't. But right there, right above my finger, because this wire's in the way. Okay, so we know where we are for sure with this terminal. This terminal is, let me get this right, this terminal, number 1. So we go on the other side here, and we should be able to start tracing towards the wire. So right away we have a terminal right near the top. And I'm afraid I can't have my hands here and on the diagram at the same time. So, actually, look, I left a hand on the diagram. Hey, look at where that hand is on the diagram. We see this connection. Then we see 2 missing connections, or 2 non-connected terminals. But look, they are connected. There's a connection here and a capacitor, and a connection over here. But they're on the other side. They're on the front side of this wafer. So on the back side, there's actually 2 missing. 1, 2, nothing happens. So we look at the diagram, right where my hand is, you can see 1, 2, nothing happens. I'm going to move that hand over to here. There's the other 2 connections on the other side, the front side. Okay, so we've made it all the way to number 3 here, if we like. Number 4, actual number is 9, because they're numbered this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. So number 9 is what we're trying to spot. Next one past the 2 that are on the other side. So we go 1, 2. Now you're going to have trouble seeing this. I'm having trouble seeing it. Way back here. It's connected to a wire. If I follow that wire, oh my gosh. Much easier said than done, believe me. So easy to make a mistake doing this. Trace the wire. The wire is going way down here. Really? This is it, way down here? Sure enough, that's it. Yes, without a doubt. This wire, wherever it's going, where is it going? Through the chassis. Sometimes they show that on the schematic, a wire going through the chassis. Up to the top here. Big chunk of dust. Just taking a moment to remove a ball of dust. No, it doesn't want to come out. Okay. So if we look on the schematic now, the 3rd wire, let's see where it goes. The 3rd, so that's this one here, it's this one. Oh, it goes up to the capacitor, up on top. Okay, so that's proof positive I've got the right wire here. Now we'll go on to the next wire. Okay, the next wire over, even back further. It's really hard. I'm really having trouble seeing myself in here. So we traced this one. And the next connection, I'm trying to look down from the top here. It's not working out too well. You can't see me, but I'm weaving and bobbing my head all over the place to try to get an angle on this. So that's the one going down there. And then the next one. the next one appears to be this. So I just have a little bit of trouble focusing. At my age, of course. I'm going to put on my magnifying goggles here. See what we can see now. Wow, that's very interesting. Okay, so I can see this wire. It's coming to a terminal on which there's another wire. It's this wire. This wire curl behind this capacitor. The wire curls around like that and reaches a terminal on the coil here. So we should find a wire. So we found one wire going through the chassis to the capacitor. The next wire is supposed to come over to the coil. Okay, looking at the schematic now. So that would be this wire. Up to a coil. There it is. It's the broadcast coil. Okay. Then the next connection, it's very, very difficult to see here what is going on. So on these diagrams, you'll find short arrows like this, and then there'll be a long arrow. See that one? That's longer. And on this is the piece that rotates. This and this, they rotate as you turn the control, and they contact these different contactors. These pieces have also short and long pieces. So the short piece is here, and the long piece is there, underneath this arrow. So it's kind of a smudge. Here you can see this one. You can see this one really clearly over here. So you can imagine the long arrows reach the inside. The short arrows are waiting for this piece to come along and contact them. That's how these switches work, not only on the diagram here, but in reality. That's exactly what they look like. So, oh, well, you know what? So this is shown in broadcast mode and broadcast band, and to go the next step, looking this way, it's going counterclockwise. Looking this way, it's going counterclockwise. Counterclockwise on the rear. So as you rotate the switch off of AM, this whole piece is going to rotate this way. So first snap off of AM, this no longer contacts this piece. This piece is rotated, so this ground piece is now connected to these two. Or did this one come free? Did this piece slip all the way under? I can't absolutely be sure. Looks like it to me. So this would become disconnected. So they would. So in the first radio mode, how can this become disconnected? It's got to be connected here, doesn't it? How's that going to work? I don't know. I'm not. This is why I hate these switches. Right? I can't analyze them without spending an extraordinary amount of time on them. And surely it's not necessary. So which of these terminals is the mystery wire connected to? Okay, so now I'm going to try to figure that out for sure. So we know it's one, back, next one. It's not that one. Would be connected to the first terminal appearing again. Is that right? No. The second terminal. Connected to the second terminal, and it always appears to have a ground on it. So, okay, second terminal. Looking back at the diagram now, second terminal needs coming down this way. 1, 2. Second terminal is this one, and this is the one that goes up. Let me just look again. connects to the top of the coil. Wait a minute, I got something wrong here. Yeah, first one goes out, second one goes up to the top of the coil. So that extension wire is coming from the top of this coil. What is it doing? It's coming out. Well, now what is happening here? So these pins are numbered separately. 7, 8, and 9. So even though this is kind of all schmoshed together on the diagram, it's not in reality. In this particular position, this number 7 is not connected to anything. That's what I think. As soon as you snap this thing, one snap, the ground is brought in and grounds out some of these wires here. Oh my gosh. I'm not gonna. Yeah. So as I rotate the band in broadcast position, there should be no ground attached to where the wire is coming out. The wire is coming out on 8. The mystery wire, which is not shown on the schematic here at all. What is going on? So, now did somebody put this mystery wire in here for a reason? And then just cut it and left it? I don't know. I mean, it's an original style of wire. It absolutely matches these other wires. It's got to be original to the radio. Oh my gosh. I'm not getting any kind of answer as to what this wire is doing there, and most importantly, is it supposed to go somewhere? Is this the reason why the radio is weak? Son of a gun. The terminal it's connected to. Wow, it's so tricky to look down there. How come there's a ground on it all the time? How come there's a ground on it all the time? Let's be sure of that. Maybe I made a false observation. So I'm going to clip my meter into the circuit. So just getting some clip leads here. So there can be no question about the meter. So just grounding one side of the meter, and the other side. And put on the wire. Set my meter to continuity, so it's going to give a tone if there's continuity. I'm going to switch this. It makes no difference. Is a ground always in place there? That's not what the schematic shows. It's going down to the second connection. The next connection is the ground connection. Let's look at that diagram again here. Or maybe, okay. Next connection is the ground connection. You snap the switch 1, the ground goes in place. 2, the ground stays in place. 3, I think the ground comes off. For some reason it doesn't make sense to me why they would have it that way. This is also connecting this, this, and this. What's this? What's this guy? Oop. Going away. Well, this is the actual signal. This is where the radio signal is reaching the mixer tube. On this schematic they call it a converter tube, by the way. It's got various names here. Come back. Well, that means there always has to be something fed up on this wire. I mean, if there isn't something being fed up on this wire, there's nothing coming out of the radio. This is the antenna signal. Right here. Of course, this is a long arrow. It's always connected here. So the way this switch must work, it must always maintain some kind of connection to here. Oh, you know what? If you rotate this switch far enough, this piece starts showing up over here, and you begin connecting all these things to this line. But in AM, so there's 4 wires here. I'm sure there's probably four wires on this shortwave thing. 1, 2, 3, 4, 5. 5 doesn't count. 5 is going. Where's 5 going? Bottom wire. Yeah, it's coming over and just joining in the switches here. What's going through my head is when you have this thing switched to shortwave, then you've energized, you're utilizing this. And when you're on broadcast, you're using this. And usually what happens is, and maybe not usually, but often in radios, as you throw these switches, the things that are not being used get grounded. So they're out of the picture. So again, we snap this once. Yeah. Yeah, I'm not going to be able to sort this out. So, but now let's just go back to which one was the wire carrying the signal for sure all the time. It's this one here. It's number 12. Number 12 is goes to a capacitor. Is that true? Number 12 comes off and goes through a capacitor. I'm sure that's true. There it is. I'm going to go after that guy pretty soon too. It's carrying the entire signal. Carrying the entire shortwave signal? Is it not? It has to carry the AM signal too. It's the only way through this radio is on this wire. Well, we certainly know another capacitor that should be changed out. It's sitting right in front of the. It's this guy right here. That guy I just pointed to is this guy up here. 0.005 500 volts. Is that a 0.005? Oh my gosh. Maybe. Where's the other one? This is the other one. Oh, they're totally different. Wait a minute. There's 2 styles of capacitors in here and I never really noticed. There's this style and then this style. You can tell the difference because this style, the shell hangs over the end a little bit. And this style, they don't. Plus the color's slightly different. So that's a vintage thing, but there seems to be quite a combination in here of them. So I think they're all original. Must have been at a time where maybe these were coming out onto the market or something. These were fading away. I don't know. So this is a very important capacitor here. They're all pretty important. I'm not really getting anywhere with this wire thing. How is it there's a ground on it all the time? The actual resistance is, let me just check my meter here. It's 0. The actual resistance is 0. My meter's showing a little bit there, but 0.7, but that's nothing. Okay, that's the test leads and whatnot doing that. Debate. Well, I'm going to let it go for now, and I'm going to put this issue back on the shelf for now, because I'm not getting anywhere with it at all. Spent a ton of time here trying to sort it out. At least I understand the switch better and all that kind of stuff. That's the thing about this. When you're trying to sort something out, you're providing yourself with an opportunity to learn more about the radio and the early stages. The more you run around doing crazy stuff, the more you're likely to see things like this wire hanging out here, or this thing, or you know, this thing here. Just the more time you spend. Okay, what am I going to do today? I got to do something today. I'm going to get rid of this, maybe this one, all the ones that are associated with these coils. Already done that one. That's it, I think. I'll do these three. Maybe I'll do this one too. Why not? But this big guy. Now, this big guy is very important generally. He's almost certainly involved in the screen circuit in the radio. The screen is another element inside the vacuum tubes. And this is to ensure there's no signals traveling around on the screens. Where is it connected? It's connected to a terminal on the second. Let's look at this too. So this is connected to a terminal on the second IF can. Red wire indicates high voltage. So we're going to try to find that. That capacitor, we would look for tubes with screens. So we could pick off this one right here. So this is the screen line that my hand is on, and we're looking for a big capacitor. So there's a 0.05. That's not a big one. And on the schematic, they can put it anywhere on this line, on the schematic, anywhere they can fit it in on the page. And I don't see it anywhere, unless I'm wrong about that. Unless this is it. A 0.05? That can't be a 0.05. That's got to be like a 0.2 or something like that. Let's look at the plate circuits here. And maybe we'll find a big fat one on the plate. And I've just made a... We shouldn't find a fat one on the plate. Well, this didn't go well either. Okay, it's hooked up to a terminal on the second IF. So here are the second IF. It's got to be on a terminal. So, no, certainly not those. A resistor, so it can't be that. Get back on here. This is the only one it could be on. It's the same one I was tracing before. No, it isn't. It's a plate. 0.25. That's probably it right there. 0.25. See, it's on the bottom of the transformer. So the signal, you can think of it as traveling through the top. You can think of it that way. And the bottom is generally hooked up to the chassis. So it's zero here. So that's zeroing. And maybe it's also zeroing this one. So it's trying to put a strong signal ground on the bottom of the IF coils. It's down here. Well, that can have a big effect too if it's not working right. But the AM side does work. And this part of the radio, doesn't matter whether you tune AM or any of the shortwave bands. What's going on in here is the same thing. Same frequencies going through here. Same basic operation. So you think, well, if it works in one, surely it would work in them all. That suggests this isn't really a high priority. Oop. Yeah. I lost track of what I was doing. Bottom here. Here. Down here. This guy. No harm in changing it. 0.25 is for the big one. If this capacitor is not working right, what can happen is signals can travel around in the radio where you don't want them. So as the signal is traveling through the radio, it's getting stronger and stronger. And so out in this area, you've got very strong signals intended to drive the rest of the radio. But that little tiny portion of the strong signal out here work its way back through the radio in various ways and show up on the grid back here, come through again for another run, That sounds like feedback. That would be feedback. Oops, I need to do that. I hope all this is visible. Maybe it's not, because the screen I'm looking at doesn't have the photo image or the camera image on it. So I apologize if occasionally what I'm talking about is hidden from your view. Not paying close enough attention here. Well, we'll do this big guy. We got to do him sooner or later. Do him now. Do him and test the radio. Do this and test the radio. And then do the rest of those three. The three, was it 3 or 4? Okay, that's a plan. I got a plan. I'm gonna act on it now and stop talking. Okay, so I've got a new one installed here. This is actually a bigger. Oh, really? Peanut. It's a rainy day, so I've got unhappy cats in here with me. So this guy's ready. I haven't soldered him yet. I think I'm going to go after this big one. You know, big capacitor, big job. What's this one doing? It's also tied to the chassis. I suspect it's doing something very similar to what this guy was up to. Where is it connected? That's a good question. Somewhere in that schmozzle there. So I'm going to figure that out and replace that one too. Figure out what it is first. Okay, so I've nipped away the one end. You can see where the other end's going. And I can sort of see. Okay, so it's on. Looks like it's on one of the 2 output tubes. Yep. Well, it's connected to a terminal of the socket of one of the output tubes. Sometimes the terminals on sockets are actually free for use. They actually don't connect to the tube. So just seeing a connection on a tube socket doesn't mean the tube is involved, but it probably is. A lot of stuff connected right here. Looks like 2 terminals soldered together there. Let's take a closer look because I can't see too clearly. Sometimes when 2 socket terminals are close together and need to be connected together, they kind of squeeze them and solder them. Now notice, it's a little hard to see, but you can see the solder area, and below it you can see the pin socket, the pin grip. You can see a pin in one of them. Well, there's no pin in the other one. What am I seeing there? That's not at all what I'm seeing. Yeah, it is what I'm seeing. So is this tube missing 1 pin? Or is that the starting, where's the key? So I'm looking at that black plastic part there, trying to spot where the key is. There it is. Okay, now I can count up. So this would be pin number 8. So starting with 8, counting backwards, 8, 7, it's on pin 6. Pin 6 and pin 5 appear to be shorted together. Pin 5 appears to be missing on the tube. Count them again, just to be sure. Starting right there, 8, 7, 6. Wait a minute. I'm wrong. So what I said earlier about there being a spare pin position and then the radio designer using it, that's what's going on here. So he's just connected this capacitor to this resistor. Okay, so we read that value of that resistor, we think of it this way: body, end, and dot. So the body is green, the end is silver, that's odd, and then the middle, the dot, which is a band, is on this is orange. So the orange thing is important. That's telling us generally the size of it. So it's green, and the other way it looks almost like blue, doesn't it? On the other end, blue with then silver down here, meaning it's a higher quality resistor. So if that was blue, it wouldn't really matter. Green, blue. Green is 5. The second color doesn't matter all that much. 50 something, 58K? 58K. So look for a big capacitor with a 58K resistor coming off it. Something like that. Okay, let's go on the schematic. It has nothing to do with that tube, so we're going to have to go hunting. Okay, so the size of this capacitor is a 0.1. There's not too many of those. This might be the only one. The only 1.1. And it's connected to this resistor, and then the resistor is tied, I think it is tied to that tube. Maybe not. Maybe another. It's tied to a terminal on that tube. Right down here. More red wires. Well, let's see if we can find a resistor like this around this tube. I mean, there's two of these tubes, so you kind of think they would mirror things, but not necessarily. You know, that could be a bypass on a shared cathode thing. Shared cathode thing. And those are definitely output tubes. 6F6, so we're jumping way down to the end here. Okay, a little bit of trouble showing this because I can't move it to the left any further. Looking for a 0.1 capacitor. A 0.1 capacitor somewhere in here. Just rummaging around. Hey, there it is. Right there. And see, it is pretty close to the output tube on the schematic. It's connected to a resistor here, 220, and another resistor up here. Another 220. So that's a totally different size. That'd be red, green, I think. Red, yellow, maybe. Red, yellow. Now look at that resistor. There's no way that's red, yellow. Okay. Is there another 0.1? When I look in the radio, I don't think I see one. I mean, these are pretty big. 0.1. Okay, I try to remember to keep this up in view on the screen you're watching. Looking, well, how am I going to find another one? I'm lucky to have found the one I found, which I've lost track of now. Here it is. How can we prove this? So one end does go to the chassis, that's true. The other, oh here, look at that. There it is, I missed it. 56, right there. 56K, there it is. So, so they're showing the high voltage here on the heavy line, and then they're showing, well, they got a 500 volt rating here, so I should just follow that. 0.1 capacitor. Now, what's it doing? So it's involved with plate, but it's between these resistors here. Plate. Not exactly sure what this is up to. Now we're in the audio area of the radio. One of the things, this could be what's going on here, because this is on the plate of both these output tubes. Whoops, here are the output tubes. What are you talking about, Jim? This isn't the output tube. This is the amplifier and an inverter. Plate of the amplifier and the inverter. It could be that this is just a filter doing its best to get rid of any RF that remains before the signal's passed into the final tubes here. The remnant RF, I think, is an issue all the way to the speaker. So there's filters installed here and there to try to continually knock it down. Because, you know, after all, the signal's going through amplifiers. Everything's getting stronger, including stuff you don't want. So build it up, drain it out. Build it up, drain it out. Drain it out. Build up everything, drain out what you don't want. That's what I should say. Build up everything more, drain out what you don't want. That's got to be the way to look at it. Okay, so if this guy wasn't working well, what would you get? You'd get some RF, if my theory's correct, if this is an RF filter, you get RF coming through, and eventually even into this transformer. What kind of problems that can cause, I don't really know, to be honest with you, other than just wasting effort here in these final tubes, amplifying something that doesn't need to be there. It could be as simple as that. Or maybe it's this. You let the RF get amplified in here, it's going to become so strong it's going to work its way all the way back to the start of the radio, and you start getting feedback again. Maybe that's kind of part of it. I'm sure that's part of the thinking here. Okay, so it's a quieter. Both these big capacitors are busy trying to quiet things down. Okay, I'm going to change this one, and then we'll test the radio. Okay, second capacitor is in. Just get rid of this unnecessary piece of wire here. Looks like I should resolder this a little better. It is tricky to solder onto the chassis. It's definitely on there. Just give it another whirl. Nope. Whirled it right off. Good. Just take a close inspection here. Yeah, looks good. Okay, it's time to test this radio. And, just stop for a couple of minutes and then get back at it here. Okay, let's give these two capacitors a test, find out if they really were bad or not, or how bad they are. Okay, 50 volts. Let me take a moment to charge up. Here we go. Opened up wide. 150. Yep, got there. 250. Well, nothing wrong with this capacitor. I'm going to give it a moment here, then we're going to check its size. 0.1. So I'm giving it a moment because it's discharging through this device. So 0.1. So 0.1. This would be the right scale. This one ends in 0.5. 0.5 is this middle scale. 0.1 is right here, where my finger is. So this control, when it comes over here, this should open. There we go. There it is. Right on the money. Perfectly good capacitor. But again, there's no way to know except to remove them. Once you've removed them, well, might as well replace them, right? Even if they do test good, can't really put them back in. Okay, how about this guy? $50 volts. Watch the eye. It's a big capacitor. It takes time. It's not fully open. Well, maybe it's getting there. 150 volts. Not going to open. So this one, well, it's opening ever so slightly. Not so good. Not so good. This is the one that was draining the B+. What kind of resistance would something like this actually have? I would think it's meg ohms. Let's test it with this tester. Sometimes what I'm really doing is I'm testing the testers by comparing them. So this says 0.28. It's supposed to be 0.25. And doesn't show any significant deterioration in the capacitor otherwise. If it's supposed to be 0.25 and this reads a little high, that usually indicates there's a leak. And the instruments are thrown off by that. Okay, one seemed good, the other one not so good. Incidentally, who made this one? Aerovox. Type 684. Aerovox Canada, made in Hamilton, Ontario. I have the feeling they don't make those capacitors anymore. Okay. Time to start this guy up. Take these other capacitors out of here. A little bit before I turn things on. Who knows? Maybe we're going to get more smoke. I should put this back on here. The mystery wire. The mystery wire. Everybody stand back. Volume down. Switch is on. Remove that. You have really no equipment connected. No antenna, no nothing. Yeah, I gotta stop for a minute. I gotta turn the antenna on. Okay, just did a little vacuuming in the house. Now, are we ready? Antenna's connected. Nothing else is connected. No equipment. Okay, there we go. Keep an eye on those dim bulbs. Okay. Very important in doing these capacitors, these two capacitors. Mistake here with these two, it could show up right away. But no mistake was made. Good. Swing around here. Come around here. Okay, we're on broadcast band. Volume up, please. Thank God it's there. Just a little bit nervous there, always. Okay, tuning on the broadcast band. Stations are down in this area. French ones around here. Okay, 680. $5.90. There it is. So that click, 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 click that you just heard disappearing is some weird interference here at my house that I've never been able to figure out what it is. We're only running on 85 volts here. Let's just jack it up. Oh, lots more volume. Checking for smoke. No smoke. Tick, 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 tick. No idea what that is. I mean, it sounds like a car engine. It sounds like ignition noise from a car engine. No. Okay, so broadcast band working the same. Now we'll go to the next band. Because I haven't turned the volume. I'll turn the volume up to hear the hiss. Almost full to hear it. Okay. There's the hiss. We'll tune a bit. Okay, something happening. There's a very strong station here at 9.3.
Why? Be glory through Jesus Christ forever. Amen.
Amen. On here. Ooh, there's one of those pops. Ooh, another couple. Is that because of this? Hard to say. Well, it's receiving. It's just not very good. Good. Okay, so we're going to go up to the next band. Oh, look at the volume there. That's fantastic. Does it pick anything up? No would be the answer, but using shortwave reception as a test is not very good. We're on the 25 meter band with the burned out or missing light actually. Oh, saw that noise again. Should be stuff here at this time of day. Good hiss though. Okay, and top band. Come on, pick something up. And the answer is no. It doesn't want to pick anything up. But I like the noise. So we're going to leave the volume like that. I'm going to snap through the bands. We'll listen to the noise level. Something still funny about this band. The pops are louder now. I have the volume turned right up, so that could be nothing to do with the radio. It could be something external to the radio. Those are coming from. I wouldn't bet on that. I bet it is coming from the radio, and I bet it is a failing part, but I don't know. Very good. Okay, that's good enough for today. Still have all these RF ones I didn't really get to, but that's okay. Sooner or later they'll all be changed out. So thanks a lot for watching, and have a good day.